Good morning, everyone. Thank you for the invitation. I will present new technology based on flexible adhesives. As Celeste said, I am professor of the Cracow University of Technology, but also the CEO of the FlexAndRobust company, this spin-off with my university. So when we are considering the catastrophic events and the structures, so in this case, we have the problem because structures collapse. We would like to propose some solutions for that. For years, we are using concrete, 60 years, we have the structures that are working for us, but they are corroding, There is the deterioration of this system with time, with some corrosion process of the concrete and of steel. So we are shortening the life cycle of the reinforced concrete structures. It is known that the surface of this concrete is weak due to corrosion. So we have problems with bonding area when we would like to attach the composite. If we do nothing, we can we can expect such damages like immediate and sudden falling down of the bridges. So there is, of course, a solution. We can use the composite as the strengthening material, but the requirements of the FIB guideline is that we can use it when the bonding strength, I mean the pull-off, is at least 1.5 megapascal. Is the solution for lower value? I will talk about this. So nowadays we are using the polyurethane, polymeric resin as epoxy, FRPU, also FRCM system as Christian presented, and also the new generation PolyUrethane Flexible Joints. It is used for fiber steel reinforced polyurethane system. And this is able to bond to the substrates with lower strength. This is the presentation of the effectiveness on shaking table test real scale system strengthened with FRPU. So global stiffness was increased from 21% to 77%. And also the same specimens was, how to move video? How to remove the pointer? Christian, can you help me?
Just press this. Oh, there you go.
Okay, thank you so much. So now I would like to show the movie. This is force vibration test resonance, so equivalent of many strong earthquakes, and the structure survival. I apologize for this right movie. So now when we are using composite materials as strengthening, I mean FRP, in this sense we have stress concentration that cause the lamination. When you use CFRPU system, I mean the flexible polyurethane as an adhesive, in this sense you are able to transfer high loads and high deformation simultaneously, but also to protect structure against collapse. So how to solve the problem of the stress concentration? It is quite easy because we should redistribute the stress more evenly, when we use flexible adhesive. If we are considering shear stress, of course, we have stress concentration related mostly to stiff epoxy adhesives. This is here, but when we use flexible polyurethanes, we redistribute the stress more evenly. This is like the competition with a rope, On one side, you have a strong guy. On another side, you have children from kindergarten. Who will be the winner? 100 children should be enough. So when we have the mineral mortar or mineral concrete, the crack starts due to micro cracks, due to stress concentration here. When we redistribute the stress more evenly, we can reduce this stress and also increase the capacity of the structure. So let me assume that the corroded weak concrete is a brick. This is the brick that was damaged in 4-point bending, so repair with cementitious mortar. We don't recover the original strength of the brick. When we bond it with epoxy, we increase only 7% due to this zone with micro cracks. When we bonded it with polyurethane, flexible polyurethane, we increase 90% of the total strength. So it is better to break the brick, rebond it, and use. So when we have stress concentration according to shear, as Cristiano presented, in stiff epoxy, we have direct attack of the crack on the composite material. When we have flexible material, the composite is protected because the stress is more evenly redistributed. So when we compare two systems, on the right-hand side, stiff epoxy, on the left-hand side, flexible adhesive, you can see that for the same load, we have more effective use of the composite material according to these strains measured on the surface. So also, the damage is not sudden. Go to fracture energy. Typically, using FRP, we assume that the substrate is the more critical element, yeah? So the stress concentration is cutting that. When we do not have effective bonding length, so in this case, we have this curve. When we reach the effective bonding length, for epoxy, it is quite short bonding length, we fully use the properties of the system. But in the case of flexible polyurethane adhesive, we don't found the effective bonding length yet. So I will skip the introduction according to single lap shear test because Cristiano presented it very effectively. I will present two composite fibers, I mean ultra strength fibers from steel and carbon fibers. There are single lap shear test results. In yellow, you have epoxy adhesives. One is with polyurethane, one is with carbon, another one is with steel. So mean value is about 7 kilonewtons. When we applied polyurethane adhesive in the same system, you can see 12. But what is very tricky, when we replace in the same system carbon fiber with bamboo fiber with grass, we also receive 12 kilonewtons. So the adhesive is the critical and crucial point here. So also when we compare epoxy with polyurethanes, polyurethanes are stable up to 200 Celsius degree in elevated temperature, whereas epoxy is losing their properties. So it is presented here according to Young modulus. So this curve is stable with polyurethane, and two composites, two epoxies lose their properties in elevated temperatures. So coming to FRCM system. FRCM system, as Cristiano said, is the sandwich of fibers and mortar, yeah? In this sense, we used mortar only at the bottom, and we bonded at the top with polyurethane flexible matrix. The blue one is when we don't use the mortar. The C is when we use cementitious mortar. L is when we use lime mortar. So, can we assume that lime mortar is the deteriorated concrete? Let me assume. In this case, when we compare with some literature, this is the same area. So you can see the effectiveness of FRPU and also some FRCM systems compared with this polyurethane system. It is much more effective, especially much more ductile. So when we go to structures and sudden falling down, the safety should be first, yeah? So we should protect the structure against that. And flexible polyurethane flexible joints adhesive were developed by FlexAndRobust System to keep the structure on the position. I will now present you some movies because They are not implemented here.
I don't think you can present them.
Pardon?
You can't present them on the screen like that.
I can't. How to move
I'm not sure.
it to the screen?
I tried sliding it to the, maybe it's on the other screen, but I don't think we can see it. Move it, try moving it.
Oh, like
Okay,
this.
okay.
Oops. Oops. No,
All our
doesn't
members
work.
are passionate about making sure that the repairs we do on concrete last for a very long time.
Here,
So from a restore, repurpose,
where's that video? Here?
Video is here.
Uh-oh,
No, not this.
that's all right.
Ma
This
may
one?
I?
Uh-huh.
May I?
Okay, now I'm gonna grab it, I'm gonna grab it. Oh, no, I don't think we can, I'm sorry.
Oh, it's working.
Okay, try,
Yeah.
yeah.
So in this case, when you can see, there is warning of the system. Yeah, the structure is deflected, and before the action, it is warning. So next one, more flexible adhesive. At the end, when we unload it, you can observe that it rise up. It is not reverse moving. So in this system, we can protect the structure and hang the cracked structure on the position. So coming back. Okay. So another case, we have completely cracked concrete beam, 3 meters long. So there are 3 composite materials, 2 on epoxy on both sides and 1 on a very flexible material in the middle. During the loading, both carbon fibers on epoxy detached and everything was hanging on this flexible polyurethane. So you can see when we assume the design point here and we go to the ultimate point, in these points, the carbon fibers detach on the epoxy resin. From this point, everything started to hang. So we are still over the design point. So also, as you can observe, the slip at the end of the carbon fibers. With epoxy, there is nothing till the moment of the damage. But we have continuous process of observation when we have flexible adhesives. What is tricky? Here we add safety in the system. Yeah, more ductile behavior of the structure. So confirmation from the NSM system, research done in Portugal at Minho University, 2 carbon fibers with epoxies and 1 carbon fibers with polyurethane. So we tested it in pre-cracking and after cracking repair. So you can observe that the blue one and red one is epoxy, green one is polyurethane. So you can clearly see that there is sudden failure, but with polyurethane, we have stable, almost working after the damage, post-failure behavior. So this is safety. Also, we can integrate the carbon fibers with fiber optic system to measure the real life of the structure, yeah? To have not only before the damage the information, but also after. So, as summary, we propose to use this system to protect bridges that are old and corroded against damage. If you would like and you would have to maintain the system, yeah, you do not have time to repair 100, 200, 1,000 bridges immediately in one time. If you bond this system, you are protected. You can hang it in there is unexpected event. So we can use it simultaneously with classical strengthening system. So in this sense, this is additional amount of safety in the structure. So in this graph, I would like to show that we can overcome the limit of the time that is constrained by deterioration, yeah? So we can enlarge the using of time. Also sustainability, because if we don't remove the structure, in this sense, we make them more sustainable. And this safety tape enlarge the life cycle of existing, I mean corroded concrete bridges. Also increase safety related to enormous excitation, because we never know when we overload the structure. And it can be quickly installed on the system to protect against catastrophic earthquakes and also against sudden failure. Thank you very much for your attention.